Hey guys, this is Thatcher from Leafcloud, the truly sustainable cloud. In this video, I'm going to show you how you can run a production-ready database on Kubernetes. Now, running production-ready databases is typically very hard because the thing that's overlooked is that you have to consider something's going wrong. Maybe you drop a table, maybe something gets corrupted, something else. You really need the backups and the restore process to be as solid as your database itself. Otherwise, basically, it doesn't work. And so in this video, I'm going to use kubedb and kubedb stash, which are Kubernetes operators that's going to make it easy for you to run in different configurations a database. And the example I will take here is Postgres, and also to automate the making of backups, and then also do the restores. Now, I'm not going to show the restores, but I'm going to walk you through the entire process of installing the Postgres database, setting up the backups, and this whole flow, and I'm going to show you this in code. So what you can do, if you want, you can follow along with me. I have shared all the files that I'll be using in this video on this GitHub repository, so that's dhrp/kubedb-stash-demo, so you can follow along. I also have a Rancher Kubernetes cluster set up here, and you can see that I have already set up a tardigrade gateway. This will be the backup target that I'm using. Tardigrade is basically a distributed object storage. So it's basically S3, but for people who are not using AWS, and it's also pretty awesome. But for the purpose, as far as this video goes and the usage goes, any S3 compatible backup storage location would work just fine. So let me show my files here. This is the repository I just showed you on GitHub. And in here I have a number of steps which I have used to install the apps code operators, if you will. So, and I'm not going to walk through these. I will focus my time here on actually installing the database, but I'll just show you the steps that would be required. You add the Helm repository to your cluster. You update it. Then you can install the kubedb community operator. The kubedb operator can facilitate installing many types of databases. This includes Postgres, but also MySQL, Elasticsearch, Redis, MongoDB, and others. And is open source, free to use. The more advanced features that I'll be using in this video, they belong with the enterprise version. The license you can fetch from their server, have an online portal for that. And then you would also install the catalog. So first, let me show these things and how they would work. So I'm going to switch to the kube system namespace. And I'll do Helm lists. So here you see that I've installed the kubedb community and enterprise versions. I'm going to show the CRDs. These are the custom resource definitions. So in case you're not familiar with operators, an operator on Kubernetes is a pattern to start services with specifications that the author or creator can make. So basically, the system that I'm going to demo uses this a lot to watch these kind of resources as you make them, and then make the reality to reflect what you need. And so these custom resource definitions are the definitions of the kind of things that you can make. So what we have here: Memcache, MongoDB, PerconaDB, Postgres, Redis, etc. So these are all databases that you can install later on. let me also show kind of how this in reality works. So here you see that there are actually like a few pods just running. These are the operators. They are the services that actually watch the Kubernetes API and see if something changed. They will make sure that this actually happens. Okay, so what else do we have? We have the catalog. This is the catalog that I actually already showed, which shows all the different databases that they support. Now we also have Stash, which I also installed. This is the program that is responsible for making the automated backups. So it can make automated backups from databases, but really of all sorts of things in your cluster, including persistent volume claims, so volumes and other things that you have. Let me show that as well. These are what you call tasks. Now you see here the PVC, so this is persistent volume claim backup and the persistent volume claim restore, and all the different Postgres versions. Now these are here because I have already installed them. There's the Stash Postgres add-on, which is basically also a resource with Helm, and it has well, I've installed this, which then makes it specifically available to have all the Postgres specific tasks. These are not all installed all by default, because otherwise you would have like a lot of different options, especially because there are so many different databases supported in the system as well. This is where basically I'm going to start showing how you then actually run a database. And we're going to do this in real life. So I'm going to switch to the Postgres demo namespace, and I'm going to switch over to my project here, where I have another make file, which you can also use to follow along and to see all the different things that we needed to do to set up that database. Now, the first one I'm going to show is to actually just make the database. As you can see, this kube spec is really like simple. It just says that there's a type of resource called Postgres. Again, this is using the custom resource definitions. I specify the version here, storage type, so it will also create a persistent volume claim and persistent volume if your backend supports it. And then I can specify what kind of storage I want. And it has a termination policy, which kind of neat, because it will actually like prevent you from deleting it by accident as long as this flag is set. Now there's a lot of more options that might go in here, like for all sorts of things, for how you want to configure it. You can have a leader and a follower database, a hot spare, a warm spare. You can specify the resource limits and requests for this database and so forth. And for now, I'm just going to make it simple. So let me go to folder, and I'm going to apply this. So let's see what happened. Okay, so we got a pod which is being created. It creates a service which is exposing on the common port that we know from Postgres. The pod is running in a stateful set, which means that the pod will try to stay on the node or on the machine on which it was initially started. This is good because if your volume is mounted to that, it will stay there, won't jump around. And this is the actual Postgres resource definition style, and where you have it. Okay, now we can say it's ready. I could also do get Postgres, or describe Postgres Postgres, because it's called Postgres. You can see that the operator actually created all these services with all the different standard configurations. But you can see it's running. Next, what I'm going to do is I'm going to make a repository into which I'm going to put the backups. Now, what I have is a this is target. In this case, it's my own version of S3 that I'm running locally here on the cluster. It's outside the scope to go into detail of it, but it's really similar to S3. And so what we're going to do is we're going to make a secret with the restic password. Stash uses restic, which is which does a lot of the fancy incremental backups and so forth for us. But it also means that you encrypt all the data before it even leaves the cluster. So if your S3 repository would be compromised in some kind of way and an attacker gets access to it, you don't have to worry, because as long as they don't have this password, they cannot decrypt the data and know data is lost for you. So here we have the AWS access key ID and the secret access key. They're basically plain strings in these files, as well as in the restic password. So now we're just going to make this make the secret in our namespace. I'm just going to do it like this. And so here we'll see that there's now a target-grade secret created. So this is just the credentials to your S3 bucket, if you will. Note we also have a Postgres token and Postgres auth. These were automatically created when we created the database. Now, next thing we're going to do is we're going to create this repository. So this is basically the definition of the thing or the bucket in which we're going to put the backups. So a bit smaller there. The backend we're going to use is S3, and we're going to specify the address here. Now, because target-grade is running within my cluster, I can just use a local service address, but otherwise you would use AWS or whatever else have you. The name of the bucket and the prefix. So I'm going to put it in backups demo, and here there's a reference to the stored secret, the one we just created. I'm naming this one the target-grade repo. So we're going to use that reference in a bit. So I'm just going to do this. There we go. So we can now do get repository. So now we'll see that we have created a repository that is just in existence, and we see that there were no earlier successful backups or snapshots counted here. But so far so good. Now next step is that we need to make a well, there's two things we need to make. We need to make the backup configuration, but we also need to make a what they call an app binding. It's basically a tool to link the backup configuration to a particular name of the database. In this case, I'm showing you the backup configuration that we'll be applying in a little bit. So there's the name of this backup configuration. The driver, which is restic, it's like how we do the backups. The repository is the one we just created, the target-grade repository. Then there's the task, which we had talked about in the beginning. So there's these different tasks that are available. So as you can see, there's the different options for backing up different versions of Postgres. Again, like as long as the major versions match, it should work. So you can run a 11.2 database with the 11.9 backup target task. So here I'm using the latest 10.14 version. And then here we're going to say, okay, what's the target of the thing that we want to back up? And I'm targeting an app binding with the name Postgres. Now, I don't have an app binding yet. My apologies, I actually do have an app binding, which must have been created automatically during the creation of the Postgres database. Perfect, actually. Okay, perfect. So then we can just continue with the backup configuration. Let's see what else is in here. Again, we covered the driver, the repository, the task that we're going to run, the target, which is then now the binding to the database, if you will. The password and everything that belongs to the that gives access to the database is stored as a secret, as we had already shown down below here. And so the stash can just use that same password to get access to the database. Now, in my example, I have a schedule that does a backup every minute. In practice or in production, please don't do this. It's going to be like a pain in the ass. And if your database is big, it might actually also create a significant load on your database. And in our case, it's not what we want. Notepad, there is a backup history limit. This is for us to see some history of prior backups, which is useful for debugging mostly. And then this part is also really interesting. It's the retention policy. As you know, like if you often do backups and you want to do this for a month, then you might see that you have tons and tons of versions. Stash is clever, and it can say, okay, so I want to keep one version for every hour, one version of every day, and one version of every month, and then one version of every year, and so forth. So that you have increasingly fewer dense backups, but increasingly longer back. It's for when it happens that someone says, oh yeah, I think it was there, but do you know when? Like, you can actually go back further in history without having to carry the big weight of all these kind of things. Plus, you can say something like, I want to have no more than X backups, and all the ones in between will be purged. This is really useful because otherwise your storage can get out of hand real fast. But depending, of course, on the size of the database that you're backing up. Before I apply this, I'm going to show you what else we have here. So here we see that we have the Postgres database, and this is in the Postgres demo namespace. But also, I'm going to show you this. This is, if we go here to the target repo, this is the source of it. So here we have that the bucket. It's called database backups, and as you can see, it's still empty. So this is where we expect that that will show up. What's cool about Tardigrade is that it essentially has a S3 compatible gateway, what they call it. So you can use it with the Minio browser and see what's in there. So now we have walked over all the different parts of the backup configuration, and we're going to see if it actually works. So I'm going to apply the backup configuration. Yes. And I'm going to do BC, which is short for backup configuration. You'll see here that it has said, okay, I'm going to have this name, this is the task that is connected to it, the schedule, where it's paused, and the age. And then what we can also see is we can get the backup sessions. Look, okay, so we have already one backup session going on. Let's wait for the new one to be created. Let's see. Running, that's good. Let's have a look in here. So this is the pod that is responsible for actually like starting, connecting to a database, dumping the files, was like a PG dump most likely, and then uploading it to the storage. So let's see. Okay, gets repository. Okay, look, there's been one snapshot. It was done last successfully 46 seconds ago. We can also get the snapshots. Good, created. And then, of course, the proof should be that we have now a snapshot version here in our database. Okay, look, there's now a folder backups, demo. Great, so I have snapshots here. Great, we already have two. One has been created just now and the other one a minute ago. Snapshots. No. So I believe when you fetch your snapshots, it actually connects to the bucket to see what is there and then like returns. So this is looking good. This all looks nice and healthy. And with that, I think I'd like to end this demo. I hope that you've learned that you can actually use the operator pattern to develop a database that has backups. And I would recommend you to leave some comments, share this video, talk to me, drop me a line. I'm just going to enter my email address here. So you can reach me there or on Thatcher, at DHRP, which is me on Twitter, where I have my GitHub. So please reach out and thank you. See you next time.